Hey everyone, welcome back to the channel. I hope you are doing great. In today's video, we are going to learn one of the most important concepts in Unity, that is raycasting. By the end of this video, you will understand what a raycast is, how it works, and we will build a simple project where we can look at an object, press the E key, and that object disappears. This is one of those Unity features that you will use in almost every game you create. Whether you are making an FPS game, a horror game, an adventure game, or even a puzzle game, chances are you will end up using raycasting somewhere in your project. So first let's take a look at the final result. As you can see, I have a few simple objects placed in my scene. Whenever I look at one of these objects, Unity detects it. If I press the E key while looking at that object, it disappears from the scene. Let's try it. I will look at the cube, press C, it disappears. Now let's look at the sphere. Again, I will press C, it disappears as well. The same works for the capsule and the cylinder. The logic behind this is actually very simple. The player isn't clicking on these objects. Instead, the camera continuously sends out an invisible ray. If that ray touches an object, Unity tells us exactly which object it has hit. Then when we press the E key, we simply destroy that object. Now before we start writing any code, let's first understand what raycasting actually is. Imagine you are playing a game. You are standing in front of a door. You press C, the door opens. Or maybe you are holding a gun. You fire a bullet. How does the game know which enemy you shoot? Or maybe you are looking at a key. You press C, the key gets collected. Or perhaps you are looking at a treasure chest. You press C, the chest opens. But there is the question, how does the game know exactly what you are looking at? The answer is raycasting. You can think of a ray as an invisible laser. It starts from one position and travels in one direction. If that invisible layer touches an object, Unity immediately tells us which object was hit. Once Unity knows which object was hit, we can perform any action we want. For example, opening a door, pick up a key, destroying an enemy, collecting an item, talking to an NPC, or activating a button. That is why raycasting is one of the most important concepts in Unity. Now that we understand the basic idea, let's build it ourselves. I am starting with a new 3D scene. The first thing we need is some ground. So I will right click inside the hierarchy, go to the 3D object and create a plane. I will rename this plane to ground. Now let's create a few objects that our ray can detect. Again right click inside the hierarchy. Go to the 3D object, create a cube, now create a sphere, then create a capsule and finally create a cylinder. I will move these objects a little apart from each other so they are easier to test later. For this tutorial, these simple objects are more than enough because our main focus is understanding raycasting. Before we continue, you might be wondering how I am moving around the scene. I already have a detailed tutorial on creating a first-person controller in Unity. If you haven't watched that tutorial yet, I highly recommend checking it out first because I will be using the same controls throughout this video. I will leave the tutorial as a card at the top. If you want to know, just check it. Now let's continue. Now, I also want a simple crosshair in the middle of the screen. This isn't required for raycasting to work, but it makes testing much easier because we always know where the camera is pointing. So let's create one. Right click inside the hierarchy, go to UI, create a canvas. Inside the canvas, create an image. I will rename this image to Crosshair. Now I will reduce its width and height to around 20 by 20. Finally, I will anchor it to the center of the screen. Now whenever we play the game, we always know where our ray is pointing. Our scene setup is now complete. Now it's finally time to write some code. Inside the project window, I will create a new C# script. I will rename it Raycasting. Now I will attach the script to the main camera. The reason we are attaching it to the camera is very simple. We always want our ray to start from the player's point of view. Wherever the player looks, the ray should also travel in that direction. Let's open the script. The first thing I am going to create is a float variable. Public float ray distance is equal to 5f. Let's understand why we need this variable. Whenever we create a ray, we need to decide how far it can travel. Think of it like a flashlight. It only lights up objects with a certain distance. Our ray works in a similar way. The value 5 means our ray can only detect objects that are within 5 Unity units. If a object is far away than that, Unity simply ignores it. Another advantage of making this variable public is that we can change its value directly from the inspector. If later we decide that 5 units is too short or too long, we don't need to edit the script. We can simply change the value inside the script. Now I am going to create a one more variable. Public LayerMask interactable layer. You might be wondering what a layer mask. A layer mask allows us to choose which objects our ray is allowed to detect. Imagine we don't use one. Then our ray can hit everything in the scene. That includes the ground, walls and any other objects. For this tutorial we only want our ray to detect the objects that the player can interact with. So later we will create a new layer called Interactable. We will assign our cube, sphere, capsule and cylinder to that layer. the ground will stay on the default layer. This way our ray ignores the ground and only detects the objects we actually want to interact with. It is a much cleaner and more professional way of using raycasting. Now let's move inside the update method. We used the update method many times before. Unlike the start method which runs only once when the game begins, the update method runs every single frame. Since the player can move the camera at any time, we need to continuously check what they are looking at. That's exactly why we are using the update method. Every frame Unity will send out a new ray from the camera. Inside update, the first thing I am going to write this ray equal to new ray of transform.position comma transform.forward. This line creates a brand new ray. Every ray needs two things, a start position and a direction. Let's look at the first parameter, transform.position. Since this script is attached to the main camera, transform.position refers to the position of the camera. This means our ray starts exactly from the camera. Now let's look at the second parameter, transform.forward. Every transform in Unity has three main directions, forward, right and up. The forward direction always points straight in front of the object. Since this straight is attached to the camera, transform.forward represents the direction the player is looking. So every frame Unity creates an invisible ray that starts from the camera and travels straight ahead. Now if we save the script and press play, we still won't see anything. That is because a ray is invisible. To help us visualize it while we are developing, Unity provides a very useful debugging function, Debug.DrawRay. Ray.origin, ray.direction into ray distance, color.red. Let's understand what this does. The ray starts from a ray.origin. It travels in ray direction. We are multiplying it by ray distance. So the red line has the same length as our ray. Finally, we are giving it the color red. Now save the script, go back to Unity, press play. Switch to the scene view. You will now see a red line extending out from the camera. That red line represents our ray. Remember, this only appears in the scene view. It is a debugging tool to help developers visualize what's happening. Now that we can actually see our ray, it is time to make it detect objects. For that, we will use one of the most important functions in Unity. Inside the update method just below Debug.DrawRay, I am going to write the following function. If Physics.Raycast of ray, out Raycast hit, ray distance, interactable layer. This is the line where the actual raycast happens. Let's understand it one parameter at a time. The first parameter is ray. This is the ray that we created a few moments ago. It starts from the main camera and travels in the direction the camera is facing. The second parameter is out RaycastHit. You might be wondering what RaycastHit is. Think of it as a container. Whenever our ray collides with an object, Unity stores all the information about that collision inside this variable. For example, it stores which object has hit, which collider was hit, the exact point where the collision happened, the distance from the camera, and several other useful pieces of information. That is why we need this variable. Without it, Unity would only tell us that something was hit. It wouldn't tell us what was hit. Now let's talk about the out keyword. The out keyword tells Unity that this variable is currently empty. If the ray successfully hits an object, Unity will automatically fill this variable with all the hit information. The third parameter is ray distance. This is the maximum distance our ray is allowed to travel. If an object is far away than the distance, Unity won't detect it. Finally, we have interactable layer. Remember the variable we created earlier. Here we are telling Unity to only check objects that belong to this layer. So even if the ray touches the ground, Unity ignores it because the ground isn't part of the interactable layer. Only our cube, sphere, capsule and cylinder will be detected. This keeps our raycast clean and prevents unwanted objects from being detected. Now here is the important part. If the ray successfully hits an object on the interactable layer, this condition becomes true. Only then will Unity execute the code inside the block. Now let's find out which object we have hit. Inside this condition, I am going to write debug.log of hit plus hit.collider.gameObject.name. All the collision information is stored inside our hit variable. For that variable, we are accessing the collider. For that collider, we are accessing the game object. And finally, we are reading the object's name. Then we are simply printing that name in the console. Let's save the script and go back to the Unity before testing. We have one more thing to do. Select any one of the objects, go to the top of the inspector, open the layer dropdown, click add layer. Create a new layer called Interactable. Now return to the scene. Select cube, change its layer to Interactable. Do the same for the sphere, the capsule and finally the cylinder. Leave the ground on the default layer. Now select the main camera. You will see our raycasting script in the interactable layer field. Choose the interactable layer. Now everything is connected correctly. Let's press play. When I look at the cube, you can see the console printing hit cube. Now I look at the sphere, the console he prints hit sphere. The same happens for the capsule and also for the cylinder. This tells us that our raycast is working perfectly. It is only detecting the object we want. Now let's make this project interactive. Instead of only printing the object's name, let's remove it whenever we press the E key. Still inside the same raycast condition, I am going to write another if statement. If Input.GetKeyDown keycode.t. We have used Input.GetKeyDown in previous tutorials as well. This function checks whether a key was pressed or not. In our case, we are checking for the E key. Notice that we are using getKeyDown instead of getKey. The difference is very important. The getKey stays true as long as the key is being held, but keydown becomes true only once at the exact moment the key is pressed. Since we only want to destroy the object one time, getKeyDown is the correct choice. Now inside this condition, I am going to write destroy hit.collider.gameObject. The destroy function removes an object from the scene. But which object should Unity remove? That is where our hit variable becomes useful again. The ray already knows exactly which object it collided with. So we simply access the collider, then the game object, and pass that game object into destroy function. That is all we need. Now whenever we look at an object and press the E key, Unity destroys that object. Let's save everything and test our final project. I will press play. First I will look at the cube. The console prints hit cube. Now I will press C. The cube disappears. Next I will look at the sphere. Again Unity detects it. I will press C. The sphere disappears. Now let's do the same with the capsule. It disappears as well. Finally the cylinder. Press C. It also disappears. Now let's look at the ground. I will press C. Nothing happens. And that is exactly what we wanted. The ground doesn't disappear because it is not a part of our interactable layer. Our raycast only detects the objects we have chosen. Let's quickly recap everything we learned today. We started by understanding what a ray is, an invisible line that starts from one position and travels in a specific direction. Then we learned what raycasting is and why it is used in games. After that, we created our own ray using the camera's position and forward direction. We used Debug.DrawRay to visualize the ray while testing. Next, we used Physics.Raycast to detect objects. We learned that RaycastHit stores and how the out keyword works. Then we used a LayerMask, so our ray only detects the objects we wanted. Finally, we checked for the E key and destroyed the object that the ray was pointing at. As you can see, the code is actually quite small, but the concept behind this is extremely powerful. Raycasting is used in the countless games for shooting object interaction, selecting items, checking line of sight, opening doors, picking up objects, and many other gameplay systems. Once you understand raycasting, you will find yourself using it in almost every Unity project you build. And that's it for this tutorial. And if you found this video useful, just stay tuned to our channel.